So anyone here used Osquery before? It's okay if you have, or it's okay if you haven't. We're going to start with the basics, and we're going to actually install it from scratch. So I'll send the commands that we use to install and download over the chat. So if anyone wants to work along with me, they can, or more likely just save the commands, and then later on you can try it on your own. So we've got Prakash just joined, Neil Mehta, hello. So for those that just joined, we're going to get ready to kick off, and if you guys have any questions, or if I'm asking for feedback with respect to some solutions for these threat hunting exercises that we do, then we'll just go ahead and type those in the Q&A box on the Zoom, and we'll go from there. So let's go ahead and kick it off. My name's Julian Waite. I'm from Uptycs, and we're going to be doing a Osquery tutorial today, specifically around threat hunting. And threat hunting, looking for malicious activity on our machines, seeing if the machines are connecting to any malicious IP addresses, seeing if any malicious files are running on our machine with respect to the file hash. Because in Osquery, we can get the file signature or the file hash and compare that against known bad file hashes or indicators of compromise. And we'll look at a couple of other things like file integrity monitoring, as well as some user event data around detecting brute force logins and things like that. So let me go ahead and move to the next slide. Basically, in March this year, India's third largest IT outsourcing company was breached, and threat actors got into their systems, and then they used Screen Connect to move laterally into other machines and gain further access into their customers' networks. So very shortly after that, the indicators of compromise were published on Alien Vault, Open Threat Exchange, and also on Krebs online security. So these indicators of compromise are things like file hashes, MD5 file hashes, SHA-1 file hashes, malicious domains, malicious host names, and so on. Here's a sample from Alien Vault of these actual indicators of compromise. And we're going to be looking for some of these on our demo system today. This is Krebs on Security. They published these IP addresses and domains and file hashes. And so we're going to be looking for these indicators of compromise as well on our system with Osquery. And we're going to do that to determine if we've been compromised on our machine. So let's get started. I'm going to log in here to my machine. And the first thing I'm going to do is download Osquery. So Osquery is open source, and you can go ahead and download it yourself. I'm going to do it right now with this command. So let me go ahead and download it. Let's see if I can see that. Okay, and I'll put this in the chat. Let me see if you guys can see this. Can everyone see that in the chat there, that wget command? I'll put it in here too. Let me know if you can see it in the Q&A. And this, of course, is for the Debian Ubuntu version. There's a version for Red Hat, version for Windows, a version for Mac. Looks like Centellia has deployed it. Got a problem for generating a packet like MSI and distributing it. Right. So what we typically do is use some kind of an automation platform. So Ansible, Chef, Puppet, or Jamf on Windows. And we use that to basically deploy. At Uptycs, we've modified the Osquery package slightly so that it's really easy to install. It's got everything that's required in it for the setup. But automation tools I find very helpful when you've got a large number of assets to deploy Osquery to. Okay, so we've downloaded it now, and we're ready to install it. So we're just going to do a sudo dpkg install on this package. So let's go ahead and run that now, and that should install that package that we downloaded. So I'll go ahead and put that in there too for the install command, and now we're finished installing. So we're ready to rock and roll. So we're going to start Osquery, and we're going to use Osquery I. It's the interactive shell. There's also an Osquery D, which is the daemon version. So if you know the specific queries that you want to run on a regular schedule, then you can configure those queries and how often they should run, and they'll be kicked off with Osquery D. But we're just going to use the interactive Osquery I, and so we'll start it as with root permissions. So we'll sudo Osquery I here, which is this. And straight away we're into the shell. So once we're into the shell, we can get access to all of the tables. So there's a couple of cool commands like tables, and they'll show you all the tables that you can select from. And all of those are also listed on the web here at this osquery.io schema. So I'll put that in here so you guys can go there and see all the different tables that you can query from in Osquery. Now, some of the tables are specific to operating systems. So if you look at this account policy data, that's only for DAO and Mac. If you look at something like IP tables, that's just for Linux, for the IP table firewall rules. If you look at something like processes, that should be on every flavor. So let's go ahead and look at processes. Processes. Okay, here, yeah. So that's on Mac, Linux, Windows, and FreeBSD Linux. So you can use this website to see what specific tables are available on the different versions. And some are available for all, but some are just for specific, like the ELF tables, for example, just on Mac. Okay, so let's go ahead and start running to show some different commands. So the .tables command shows the different tables. The .help shows you help. You can do .exit to get out of Osquery. But let's run a couple of these queries. So we can run a query to select all the processes that are running on the machine. So let's do that. I've got it here in the copy paste. And so this is going to return all of the different processes, and it's kind of hard to read, but if you limit it to certain columns, name of the process, the UID that started it, and you can use a limit clause so that you don't have to get everything. So you can run a whole bunch of different queries. Here's one that would allow you to select all the different users on the system. There's a table called users, and just look at the users where the shell is no login, i.e. only the users that can log in. So let's go ahead and run that query and see what it looks like. And then we can see all of these users, and these are the users that can actually log in on this box. I'll go ahead and I'll just paste all of these queries into the chat. So if anyone has any particular one they want to run, I can run it for them. I'll probably run one or two more. So for example, let's have a look. So this one we'll look at the processes and the process open sockets. So we'll be able to look at all the processes that are connecting to machines that are not the local machine, the loopback 0000. So if we run that query, it shows us all the connections and what the remote address is along with the process name. So you can do some pretty cool stuff in Osquery. On this next slide here, I'm showing you can also select from the etc password file. So Osquery works with Augeus, so you can put Augeus lenses on files, and out of the box you can look at etc password, etc shadow. You can create your own Augeus lenses. If you have structured files, for example, you could use Osquery to pull certain rows out of them. You can use Augeus to specify search clauses, regular expressions, and so on. You can look at the packages that are on a machine. So there's RPM packages for Red Hat, there's dev packages table for Ubuntu, and you can see all the versions of the packages that you have. So if you're looking for vulnerabilities, that's quite a neat thing to do. What we've done at Uptycs is actually we've loaded the CVE, the vulnerability database, and we run queries like this to see what versions of packages are on, and then we say, oh, do you have any vulnerabilities on any of your machines? So that's pretty neat. Let's look here. Oh, you can also select from the cron tab. You know, a typical attack vector is malware will get on a machine and put an entry into the cron. You can look at the kernel modules that are loaded, all sorts of different things inside of Osquery. So let's get looking at the malicious activity, the breach. So here are 3 IP addresses that were published in Alien Vault as indicators of compromise. So we want to look to see if our machine is connecting out to any of these malicious IP addresses. So what we're going to do is I'm just going to go ahead here and go ahead and run. I'm just going to run a little activity on this machine so that we can basically see some results. So some questions here. Is our machine connecting to any malicious IP address? If so, what is that malicious IP address? And here's a list of 3 malicious IP addresses. In reality, you would have lists of thousands or hundreds of thousands of these indicators of compromise. At Uptycs, we have about 200,000 current bad IP addresses. But for our test here, we're just going to use 3, and we're going to look to see if we can detect those. And if we do detect them, what is the process that's connecting out to the malicious machine, and what user is running that process? So how are we going to find that with Osquery? Well, here's a hint. We can look at the open sockets table, and we can say where the remote address is in any of these malicious IP addresses. So if there's someone here, if anyone wants to go ahead and respond in the Q&A or chat, based on this hint here and these 3 known malicious IP addresses, what would the SQL statement actually be? If someone can send it to me, we'll wait a minute or two and see if someone can send that in. It's basically going to be a query of this form, but we're going to plug in, instead of ABC, we're going to plug in actual malicious IP addresses that we're looking for. So we're kind of using these 2 pieces of information here. And so basically what we're going to do is we're just going to take these malicious IP addresses that we're looking for, and we'll just paste them into a SQL statement like this above here. So basically, we're going to do this. So this query here should tell us if our machine is connecting to any of these bad IPs. So let's go ahead and see if that's doing it. I'm going to just double check here, make sure everything's kosher on my C2 server. Start Osquery. Okay, so we're now detecting that we have one of those three bad remote addresses is being connected to on our machine. So we're looking in the open sockets table. So you can always use a query like this if you have a list of known bad remote addresses or indicators of compromise that are IP addresses. And if you have thousands of those, you could load them in a CSV and then expose that through Osquery and join the two tables. So process open sockets, which are the open sockets on your machine, to the indicators of compromise table. And if anyone's interested in that, they can shoot me an email afterwards and I can show you how to expose a CSV file if you have a large number of blacklist entries of any kind inside of Osquery. So that gives us the answer. Yes, our machine is connecting to a bad IP, and of these three, it's this middle one here. So next question is, what's the process? So if you look at the data here, it looks like we have the PID of 8438. So you can basically go ahead and look at the process that's that PID. And it's not running anymore. So if we run this query, this is still showing here. Okay, it's a different process. There's activities happening that's changing over time. So okay, so here if I select from the process for that PID, I did it very quickly before it changed. Then we can see all the details on that process. So we can see that it's actually the netcat process, and it's being run by this user, Danny, which has a UID of 1012. So this appears to be the account that is compromised, and he's running this command line here to exfiltrate data from our machine to this external C2 server. Okay, so I'll send those queries in the chat here, so anyone else can run them. The other one was select processes where PID equals X. All right, put that on there. So there we go. Okay, now you saw one of the complications with Osquery is that we had to run these queries at a specific time, and it would return the results that were running. So for processes, just the processes that were running at that point in time. Now that's a little bit limiting because you're not always going to be running the query at the exact time that the event is taking place. So to solve that, Osquery has created this eventing framework, and it's pretty neat. So I'll show this here just for a second. So what the eventing framework does is it's a pub/sub framework. So as soon as the event happens, like a process runs, then it'll write that process to the backing store, RocksDB. And then when you run the query later on, it'll give you all of the change data. So your query is essentially a subscriber. So the eventing framework is pretty cool, and it's used for processes, socket events for those remote connections that we talked about, and a bunch of others like Yara events. I'll see if it's got the list of them here. User events, so if someone logs on, you can capture all of that information. There's about 7 or 8 different tables that are event related. And at Uptycs, we've added the DNS lookup events. So if any of your machines are looking up malicious domains, then you'll be able to tell that as well. So we're going to start Osquery now with this configuration file and a flag file, and that's going to turn on the eventing. So now we don't have to run a particular query at a particular time to see the processes. We can just query against the event tables, and that'll give us all of the events that happened, which is really nice. So I'm going to go ahead and just run this stop Osquery here. .exit, and then I'm going to go ahead and start it with this other mechanism here. This is going to be, let's just go ahead and do it like this, actually. Start it with this flags file. So what I'm doing here is actually there's 2 things. So we're starting Osquery to enable events with this flag file, but we're also going to use a comp file. And that comp file, I'll show it to you briefly. It has in it some file paths, because we're going to monitor the user's private directories to see if there's any data that has been, or any user has been accessing them. So this is the file integrity monitoring component of Osquery. So when I go ahead and run this command, I'm going to be turning on event data, because in this flag file here, we can have a look. We have a couple of flags, including disable events false. So that means we're going to enable events. So let's go ahead and start Osquery with these configuration files now to turn on FIM and events. Okay. We've got a little notification here that syslog is not enabled on this machine. You can actually forward your events to syslog if you want. So if you have a syslog receiver for Splunk or something like that, you can do that. But for now, we're not worried about that. We're just going to query the event tables directly. So let me go ahead and this view here. So how do event tables really work? To show you the difference, I'm going to actually kick off some processes here, and that should really show you the difference. So how many rows are in the processes table now versus the process events over time? So now I just kicked off a little script that's actually running a bunch of processes on my machine. So let's have a look at the difference now between the events table, process events, and the regular table, processes. So if I was to do counts from processes, I get 175 processes, 144, 144, 170. So it's relatively static. It's moving between about 144 and 175. because there are certain processes running on my machine, and then they're stopping, and then new processes starting, they're stopping, new processes, but it's fairly constant on this machine. Now, how does that differ to the process events table? Okay. So we got 2000 in the process events table. So we got, we still got 2000. So that it's much higher than 144. And that's because as new events run, and then they stop, and then new events run again, they're going to total and add up, because the process events table has all of those events over time, whereas the process table just has those processes that are running right now. So that kind of helps you answer these questions here. In which table would you look for processes that are just happening now? You look in the processes table. But where would you look for threats that happened several minutes ago and now they've stopped? You have to look in the process events, because if you look in the processes, they're no longer going to be there, right? So that's the neat thing about the events table, and you can configure how many events you want to store. You know, obviously you don't want to overload your endpoint and be storing too many in there. But typically the way Osquery works by default with events is when you do a select from the events table, it'll give you all of those. If you're running Osquery D, for example, if you're sending those to a backing store somewhere like Splunk, or sending them into an elk stack or something like that, then once you subscribe and pull all of those rows out, they get cleared out. And then you're empty again until new events get published into the backing store. So that's how eventing works, and it's very powerful for looking at data that changed over time. So part of the eventing framework are file events. So file integrity monitoring, we're going to look at that now, and we're going to use this because we know our machine's been compromised. So we're going to try and determine, are any of the user's private contacts being accessed? And in my case, they're in this home private directory. And if so, how many different users have been affected or breached? So a hint here is that there's a file events table. So now that we're running with events turned on, we can, let's kick off some activity here on our files. And let's look at the file events. Okay, so we can see a bunch of access into our users' private contacts file. So we could do a query like, let's just select the distinct target path from file events. And we're only interested in the contacts files in this case for this question. And so we could say where it's like something like that. So here we can see that there are 5 different users that their contacts have been read on this breached machine. So file integrity monitoring can help you determine if someone's been accessing certain files, or you can configure it so that just show you when files have changed. So if you have some important production code, for example, on one of your applications, and you only do a code change every month, but you want to monitor it to see if there's been any changes in between those monthly authorized updates, then you can go ahead and put file integrity monitoring on those files and determine when any changes are made. In this particular case, I was looking for any, not necessarily changes, but any reading of those files. And it shows you here the type of action that occurred on the file, whether it was just reading it or whether it was changing it. And that's determined in your Osquery configuration. It's in your comp file. So I'll go ahead and I'll put that in the chat. So if anyone wants to run those queries, then they are welcome to do it. I'll also put the cont file in there so you can see the thin configuration. Control D exits out of there as well. This is osquery.conf. Okay. So that's the file integrity monitoring. But now I want to move on to something that's really cool, and that's the file hashes. So Osquery allows you to select from a hash table to give you the hash of specific paths, files on your machine. So if we did a query like this one here, we could look at all of the hashes for all of the files that are running on our machine. So let's go ahead and do that, see what that looks like. I'll start Osquery up again. And there's nothing running on the machine. Let me go ahead and kick off some files here on, get some stuff running. So we want to select the path of the file, the MD5 hash, from the hash table for everything that's running on our machine, for all the process events records. And here we go. We get the path of the process along with the hash for everything that's running on our machine. And why is this important? Because indicators of compromise are typically published by Krebs on Security and Alien Vault Open Threat Exchange with these MD5 and SHA-1 file hashes. So in our case, we can look for any of these malicious file hashes in this list. Okay, and so we don't have to read through it manually, we can just do it in a query. So the query would end up looking something like this, which is the above query, but we're going to say where the MD5 is in a certain list of known indicators of compromise, which is just going to be this list of 3 up here for our exercise. So that query would look like this. So we're just going to plug these guys here, and so it's going to look like this. So I'll go ahead and run that, and we do have 2 files that are this known bad MD5 hash. So I'll go ahead, I'll put that in here. And send that out. So it's quite powerful because you can look at, you don't have to calculate the hash for every single file that you have on your system, only those that are running, which are typically, you know, a tiny fraction of all of the files on your system. So you can fairly efficiently determine if you have any malicious files running on your system. So, and again, we just checked 3 indicators of compromise, 3 bad file hashes, but you could have hundreds of thousands of those. And so typically you would load those up into a table and then do a join between that threat table and the result of this selecting from the hashes for the processes that are running on your machine. And that'll show you if anything malicious is running on your machine. We'll just have a 1-minute break here just to ask questions before we move on to the next exercise. Are there any questions so far on what we've done with respect to files, file hashes, file integrity monitoring, or looking for remote open socket connections to malicious machines? You can just answer in the Q&A there, or send a question to me if you have any questions. Question from Darren: how do we get a table of hashes down to the endpoint? So if you had, for example, you can download CSV. So if we look at something like Open Threat Exchange, so if we say, look at one of these pulses here, this looks like it has 31 file hashes. So I'm going to drill into it. So here they are on the web. I think we can download these somehow. But it doesn't matter. Yeah, so assuming that you have a source of these hashes, that could be in like a CSV format, like this. Typically they have a header. It's just one row, they're not really going to have commas. So assume that we've just got a file. Then you can just use a tool to copy it to your machine. So you could just SCP it, or I use FCP. This is actually a different IP address here.
Can you hear me?
Yeah.
Question, can you use Osquery to download hashes down to the endpoint, or is it only
you
can
cannot
only do queries through the
correct, you can only do queries on it. Yeah,
but you can do a join against a CSV file?
yes. So the way that you do that is you expose the CSV file as a SQLite table, and then you can expose the SQLite table in Osquery. So I'll show you that here. So here's the first step. So you have a CSV file, and then you just run this command here. So I'll just put this in the answer. It's really, I'll just put it in this one here. So that's how you create a SQLite table from the CSV. And then the next step is to expose a SQLite table in Osquery. So and that you just put the name of the table in the conf file for Osquery. So there's a whole bunch of stuff here on custom tables. So you can do that. Now, what we've done at Uptycs is we've loaded all of those indicators of compromise into our back-end system already. So I'll show you that in a minute, but we're basically taking all of the Osquery data and loading it to the back end where we've loaded all of the threat data, including bad IP addresses, bad file hashes, and so on. And we're doing that correlation in real time. So it's really neat. Question here on MD5 hashes. Does that appear on the official page? Yeah, there should be documentation in there about using MD5 hashes or the hash table. And in fact, in here, I think there's details on the hash table as well. So you can just say select from hash where path equals, and it'll give you those hashes. And yes, Osquery can handle SHA-256. We'll go ahead and have a look at that right now. So if we said, we did an earlier query here, let's select everything to see all the different hashes. So we'll just do a select star here. Instead of doing just the MD5 hash, let's look at everything in the hash table and see what it gives you. The SHA-1 is definitely in there. And let me just limit it a little bit so that we can see the names of the columns. Okay, so you get the path, you get the MD5 hash, you get the SHA-1 hash, you get the SHA-256 hash, and you get the SSD result. So all of those are available in Osquery. And so if you look at the typical alien vault, sometimes it'll be SHA-1, sometimes SHA-256, sometimes MD5. These are all SHA-256. But if you look at a different pulse, it could be different. These ones are SHA-256 as well. They got some URLs in there. So, you know, typically malwares will come with an algorithm where they'll have a domain generator and they'll generate 1,000 different domains. And then one of those domains will actually be stood up by the threat actor. And then the malware will try all of the different 1,000 values over time until it hits the one that has been stood up. So it makes it much harder if you're doing forensics on the code. You know, if they were just to hard code one server or one domain, then it would be easy for you to determine that it's malicious. But if they generate 1,000 different ones, then they only have to stand up one, and the malware will eventually connect to it. Okay, let's have a look at the questions. I just wanted to touch on the brute force logins here. So we had a bit of a look at the file hashes, but this particular machine is a virtual machine that stood up on DigitalOcean. So it's got a public-facing IP address. So if I query from the user events table, I should be able to see logon events and attempted logins. So typically, if you have a public-facing IP address, you'll have these bots, malicious bots on the internet that are just scanning different IP ranges and trying to log on with usernames that are common, like root and so on, and just trying a bunch of passwords. So let's see if that's happened in my case. So let's run this query here. From the user events table, and we'll see how many user events we have. And here we go. So we're counting the different user events by the address that these were coming from. So we have, for example, 22 different attempted logins from this IP address. So let's go ahead and see where that IP address is registered in the world. So we're going to go to this website IP location. It shows you the location of this IP address. So this one is in New York, looks like, near Weehawken. And let's have a look at one of the other ones here. So this one looks like it's in New York as well. So this one is in Japan, Tokyo. So there's a whole bunch of different machines trying to connect to my machine just because it's public facing. So with Osquery, you can very quickly detect all of the user activity. You can select from the user events like I've done here, or you can select from logged in users or logged on users, something like that. Yeah, logged in users. And it'll show you all of the users that have actually logged in, the status of the connection, and so on. So you can look at the processes, the UID of the processes, the remote open sockets, the users that are logged on, the users that have attempted to log in. So you can see all sorts of activity like that with Osquery. So now that we've seen what we can do with Osquery on one machine, running some SQL queries, what would you need to do if you're a large organization and you had 100,000 machines? You didn't want to be constantly running these queries all the time. So anyone can kind of shoot a note in the Q&A about what they think that they would need to build, or your personal experience if you've built any infrastructure around Osquery in your organization to help deploy it to a large number of machines, or help to automate the execution of certain queries. Like if you wanted to ask a question in real time and then have all of your machines run that query and then return back the results, or if you wanted to specify a config file for your Osquery daemon and have it run queries on a regular basis and send that data into Splunk or into the Elk stack. Has anyone done anything like that, or can anyone think of the different pieces that you would need to build? So here's an example of what you might need to build. That's what we built at Uptycs. So you have the Osquery agent running on all of your different machines, Macs, Windows, and Linux, and then capturing data from those machines, as well as all containers running on top of Linux. And then in our case, we compress and encrypt it and send it up to a data store in the back end. So you might use Elk. We're using a Presto DB, but we're doing a historical flight recorder. So we're capturing all of that Osquery data over time and storing it for 30 days. So you could capture all of the data as well. And then what we've done is we've loaded the threat intel data. So here we ran a couple of queries looking for bad IP addresses and file hashes. We have those loaded from 40 different threat feeds. And we built on top of this like an alerting engine. It's like AWS Lambda, so that as the Osquery data streams in, on processes that are running, remote connections that are being made, IP addresses. We're basically correlating that with the threat data and alerting to see if there's any, bad connections being made or bad file hashes running on the system. And we're sending that alert to Splunk or PagerDuty or Slack and so on. So you can do something similar, or you can do, it's a two-way pipe that we've built. So you could do real-time queries as well to say, oh, for all my machines, let's ask this query right now to see, what's running. And so if you wanted to build something, you could build some kind of a query distribution mechanism to run that query on all the OS queries and then pull back all of the results. In addition, with OS query, because you have all of the details around what packages are running, you can do vulnerability detection. So that's what we've done at Uptycs. We've loaded the CVE, Common Vulnerability Database, and we've got a whole bunch of reports that show you if any of the assets that are running OS query have any vulnerabilities. OS query really cool for investigation, especially if you're running OS query D and storing that data on the back end, because when an incident happens, if it's a machine on AWS and it's gone offline, or if it's been deleted altogether because it was only spun up for a workload for a short period of time, then if you have all of that OS query data stored, you basically can do that investigation after the fact. And OS query is such a neat agent because it's not very heavy on the endpoint. You can configure it to run certain queries at a regular interval and store all that data, and it's really not a heavyweight agent in terms of memory or CPU usage. At Uptycs, we run a whole bunch of different queries, about 140 different queries that we run around the clock, and over a 24-hour period, we're collecting about 100 to 200 megabytes of data from all the endpoints. So if anyone is interested in seeing what we've done at Uptycs with OS query, then just shoot us an email. We'd be happy to show you. There's a little question that's come up, I think, on the screen. If you'd like to learn more about the OS query solution that we have at Uptycs, it's a SaaS service. So if you wanted to try it on some of your machines, we can easily spin you up a SaaS tenant, and you just log in, and then you can load OS query on it and then run through all of your use cases, whether it's FIM, investigation, EDR, or anything like that. I can't vote. So let me see if there's any more questions. We're getting close to the top of the hour, but if anyone has any questions on OS query in general or anything that we've covered, then feel free to shoot me a note. I'll put my email address again in here. And just put it in here so everyone can get it. So yeah, or if anyone wants a copy of any of the queries or the material, then just shoot me a note and we should be able to get it. But I think we're going to have a couple of these webinars over the next few months and covering different topics. So keep an eye out for the next invitation because we'll be covering different topics in each of our sessions. And we do have a question here from Kieran on which Linux variants are supported. Right now, I know the Ubuntu, Debian Linux, Red Hat, CentOS, and SUSE Linux. We have at Uptycs, we've typically the Red Hat 6 and 7 is supported, but we actually built out support for some legacy clients who are running Red Hat 5. What version of Linux do you have? These are the main ones. Yeah, SUSE Linux 12 and 15. So we just had a customer at Uptycs actually ask us for SUSE 12 and 15, and we support it. So if you wanted to do a trial or a POV, proof of value, then we could certainly help you. I don't know off the top of my head whether SUSE Linux 12 and 15 is in the open source version. Question from Sergey. How is the endpoint data preserved when the client disconnects from the cloud? So in the case of Uptycs, the data here is being sent into the historical flight recorder. So we're storing it in a database on the back end. It's basically NoSQL, big data, Presto DB on the back end, and it's Apache ORC files, which are compressed and columnar indexed. So we're storing it in the SAS data store that we've custom designed on the back end. But some customers use open source Osquery and send it to an elk stack or send it to Splunk, and then they keep it that way.
How do you configure Osquery in this particular setup? To what kind of data are you recording?
Yeah, so
looks like
in this
basically
particular...
this basically looks like an EDR solution.
Right. Yeah, it does. So are you referring to how do we do it at Uptycs, or how do we do it in this example with the open source Osquery?
More how you guys do it yourselves today. What do you guys configure for? What are you guys looking? What are you guys collecting currently?
Right. Yeah, exactly. So what we collect is, I'll bring up the profile. It shows you, I'll show you the 140 queries that we have. So here in our profiles for Mac, we have 137 different queries. For CentOS and Red Hat, we have 100 queries. So I'll pull up. Here's all the queries that we're collecting data from. That'll give you the 100 to 200 megabytes a day per endpoint. So this is about 99% of the tables in Osquery. So basically the types of data that you typically collect with Osquery is this, which is regular scheduled queries that run on certain intervals. And you can see those intervals can be fairly wide apart when it's configuration data. So every 60 minutes or every 120 minutes. But also there's the eventing data, which we talked about. And the eventing data is the pub sub for those things that happen very quickly. User events, click user login, processes. Process runs for a split second. DNS lookup, looks up the domain. So that is the eventing data. So we capture those regular interval scheduled queries plus the event data. So the event data is these tables here. So between the event data and the regular scheduled queries, you get all the different data that you should typically need. Now, some customers say, well, I've seen this query pack on open source and I want to run a query pack. So you can. We also do a query pack. So if you look in here, there's also these query packs. And so there are some, for example, on the OSEC rootkit to detect if you have any rootkits on your Linux machine. So custom queries have been developed to look for certain things that are, potentially indicators of compromise. You got a rootkit on your machine.
What's the load on the endpoints with Osquery?
Yeah, it's about 3%, and trying to think, like 30, 40 megabytes. The exception is if you enable event data, like if you enable FIM, file integrity monitoring, on a certain path, like /my web app, and you have a high amount of file data, or file activity, like say it's a file server and you enable FIM on those directories that are your high volume files or file server directories, then you're going to get more load on your endpoint. And so just be aware. But usually it's typically not that bad. You know, you typically monitor, like for example, you know, if you had that situation, you may not monitor every read on that file server, but you may monitor changes on certain important files, or you may monitor read on a certain smaller subset of files.
Sure. How much data are you guys collecting per endpoint today, and what's the difference between Windows, Mac, and Linux?
Yeah, the average is about 100 to 200 megabytes a day. And we collect a little bit less, like if you look at these profiles, a little bit less on Windows, because we're only doing 67 queries on Windows, because there's less OS query tables on Windows. Now, to solve this gap, what we built at Uptycs is access to the 7,000 WMI data objects through Osquery. So I can go right now and I can query on any Windows machine. Let's have a look here. Like the Win32 operating system, that's the WMI table. So I can query that on my Windows machines and run this, and I get the results back. I can look at them for all three machines combined, and I can see all that WMI data through Osquery and Uptycs. So Windows has other ways of getting some data elements that are not necessarily available in the open source Osquery.
Okay, thanks.
Okay, great. Well, we're a little bit over the hour, so I don't want to keep anyone any longer, but I really appreciate all your time. And if you have any follow-up questions, feel free to shoot me an email, or otherwise keep an eye out for the next webinar, and we'll be going over some new topics. So thanks, everyone.
Thanks.